Okay, you're gonna pause the video and on your dry erase board or scrap paper, go ahead and use a sum or difference identity to evaluate the cotangent of negative 5 pi over 12 for an exact solution. And then you can resume the video when you're ready to check your answer. So looking at the special angles on our unit circle, we're going to change these denominators to 12s since our denominator in the problem here is a 12. So pi over 6 would be 2 pi over 12, pi over 4, 3 pi over 12, pi over 3, 4 pi over 12, and so on. So this will be a 6, 8, 9, 10, 12, 14, 15, 16, 18, 20, 21, 22, and then back around to 24 pi over 12, which is 2 pi. So I'm not going to find two angles that add to be negative 5 pi over 12 because these are all positive, but I can find two angles that subtract to be 5 pi over 12. For example, here I have 15 pi over 12 and 20 pi over 12. So if I take 15 minus 20, I get that negative 5 that I'm looking for. So let's go ahead and rewrite this as the cotangent of 15 pi over 12 minus 20 pi over 12. And reducing those fractions, we'll get our special angles of 5 pi over 4 and 5 pi over 3. So now we're ready to apply our cotangent identity, and let's be careful with our notation, the difference between plus minus and minus plus as we're working through this. So the cotangent of the quantity A minus B, so we're using the symbol on the bottom of the plus or minus, we're using the minus. So when we see this notation minus plus, we need to use the bottom operation, which is the plus. Then plus or minus, we use the bottom operation, which is the minus. Now we can apply that identity, and we'll have a cotangent of angle A, 5 pi over 4, times the cotangent of angle B, 5 pi over 3. Then that's a plus because we're using the bottom operation, a 1. Okay, that's our numerator, and it'll be divided by the cotangent of angle B, 5 pi over 3. Then minus, because again we're using the bottom operation, the cotangent of angle A, which is 5 pi over 4. Okay, and that applied our cotangent identity for the difference of angles A and B. Now we can substitute in what we know, and the cotangents, as we go around our circle, remember the tangents were 0, 1, undefined, root 3 over 3. So cotangents then are the reciprocals of these values, and the reciprocal of 0 is undefined. The reciprocal of 1 is 1. The reciprocal of undefined is 0. The reciprocal of root 3 is root 3 over 3, and the reciprocal of root 3 over 3 is root 3. Now, when we take those into our other quadrants, right, 5 pi over 3 is in quadrant 4, where the cotangent is negative. So 5 pi over 3 is a negative root 3 over 3 for its cotangent. Okay, then 5 pi over 4 is in quadrant 3. Tangent is positive in quadrant 3. So 5 pi over 4 with that pi over 4 reference is a positive 1 for its tangent, for its cotangent. So now when I evaluate these trig expressions, the cotangent of 5 pi over 4 is 1. Then that's times the cotangent of 5 pi over 3, negative root 3 over 3, and then plus 1. That's divided by the cotangent of 5 pi over 3, which is negative root 3 over 3, minus the cotangent of 5 pi over 4, which is 1. Okay, now we can simplify. 1 times negative root 3 over 3 is negative root 3 over 3, and then that's plus a 1. We're going to need a common denominator, so we'll change 1 into 3 over 3, and that's going to give us a negative square root of 3 plus 3 in the numerator and a 3 in the denominator. That's divided by, oh, that's pretty messy, let's fix that. That's divided by our next value here, negative root 3 over 3 minus 1. We'll get a common denominator of 3. And then combine those fractions, negative root 3 minus 3, all divided by 3. Okay, dividing by a fraction is the same as multiplying by the reciprocal. So negative root 3 plus 3, all divided by 3. That's being multiplied now by the reciprocal of this second fraction. So 3 divided by the quantity, negative root 3 minus 3. Okay, then these 3's cancel on the diagonal, and that simplifies in the numerator to a negative square root of 3 plus 3 divided by a negative square root of 3 minus 3. If you are doing a multiple choice problem, for example, and your answers don't look quite the same, since these are both negative, we could factor those negatives out from the front of those binomials and have a root 3 minus 3 and a root 3 plus 3. And then a negative divided by a negative is a positive, and so this would be equivalent to the square root of 3 minus 3 divided by the quantity square root of 3 plus 3. And you're more likely to see it in this form as opposed to this form on a multiple choice question. In either case, you can check that answer, making sure you're in radian mode, by evaluating the cotangent of negative 5 pi over 12. Now remember, there's no button on the calculator for cotangent, so we need to use the reciprocal identity, which is 1 divided by the tangent. And then the argument of that function is negative 5 pi over 12. Oops. There we go. And that evaluates to this decimal, then we're going to compare that to the decimal equivalent of our answer. Square root of 3 minus 3 in the numerator, and square root, whoops. Oh, nope, now I messed that up. Let's try that again. Square root of 3 minus 3 in the numerator, and then square root of 3 plus 3, there we go, in the denominator. And we can see that those decimals are equivalent, and so our answer checks.